All right, here we have, okay, this is a big one. Here we need to try to concentrate a bit. Our galaxy, the Milky Way, is named after the Greeks. The Greeks said that the Milky Way galaxy, that there's like a mother giving milk to our planet. So when you look up in the sky at night, they thought, oh, this is milk coming from a woman. So they called it the Milky Way. It's 100,000 years in diameter, which is crazy big. We can't imagine that. It's so big, but we'll try later. There are about 100 to 400 billion stars. And our distance to the galactic center is 25,000 light years. Cool. Next, how big is our Milky Way?
What happened? What is that? Where are you? Quick, go away. Stop it. Stop it. Stop it. I don't want to do this. Go away.
Dude, okay, this is cool as well. 100,000 years, what is it? We can't even imagine 100,000 years. This is like from waving phones to waving iPhones. 100,000 years in human evolution. What is that? What is that? It's like, you know, our species is 200,000 years old. And it's a huge amount of time, right? And as we said before, traveling to the moon, it would take us a second. And here, 100,000 years, we practically can't even imagine that. Next. Oh, nice. So, I try to create these models. Maybe we can try to imagine kind of how big our galaxy could be if the sun were just this small thing of a millimeter in diameter. The sun. We're a million times smaller than the sun. But we'll shrink the sun to this small thing. The Milky Way will be 7.6 kilometers in diameter.
If the sun was 1 millimeter large.
Right. So that's pretty crazy. I mean, that's like from here to past the main station. It's like a huge ball. Huge. And in that, the sun is like nothing. A speck of dust.
Yeah, you would lose it. Like, where'd it go?
There's no way you could see like, you know, like anywhere, you know, from that perspective. Because you're just nothing in this huge space. And again, the world, the Earth in that little thing would be even smaller. Almost not visible. Now, we'll start traveling. Now, finally, I hope I'll be able to speak less with time. This is the Cone Nebula. This is 26,000 light years away.
In the Milky Way galaxy.
In the Milky Way galaxy, in the constellation of Monoceros. The nebula is part of the much larger star-forming complex. Cool. Cat's Nebula, constellation Draco, 1,690 light years away. It's one of the most complex nebulae forming knots, jets, and bubbles.
And most of that is gas, right?
Yeah.
Because he actually wants us all to be asking questions during his...
Oh, yeah.
Okay, I have a question for you.
Sure.
First of all, what is a nebula and how is it originated?
Right. Okay, I'll try something. Vendit, please correct me. Okay. What I've learned, a nebula is stardust. And how is it created? When is it created? When do we see it? I think we mainly see it when stars are born and when stars die, right? When there's a supernova, when a star dies, nebulae has been created.
This is the remnant of the supernova, right?
Let's have Vendor quickly.
Or some sort of nova.
Do you have anything to add?
Yes. What is a nebula really? What is a nebula? Yeah. You mean it's a supernova? After supernova.
No,
the star collapses, right?
Yes, right.
And there's a void in space, right? There's before there was all this matter and then it's gone. Well, how does that become this?
Oh, this is the gas, and we call that is a plasma. The plasma is the charge gas. So it's a positive charge or negative charge, the gas.
So it's polarized.
And polarized.
It's magnetized.
Yeah. And when it's moving, then it will have the radiation, such like the electromagnetic wave. And the most important thing is this one. This one is the we call that white dwarf star. White dwarf. Yeah. It's after the supernova. We call the supernova is a huge star. When it collapses and dance, it will have a very, very huge explosion. Then this action, this evidence, this event here, we call that supernova. Supernova is not the new star, it's a death star, but it will have a very, very huge, bright, and very, 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 very bright. And after that, this star will, if the star is small enough, then we will have the white dwarf. If it's too big, such like big 4 times of our sun, bigger than that, then it will become a black hole. Yeah. Then you can't see anything, but you will see very when it's become a black hole, then the gas will into the black hole, and it will we call that as a accretion disk. It's a disk, and it will have the jet to
right. Is that a quasar?
Yes, that's right.
Yeah, I wanted to show a quasar later, but I think we're running out of time.
Okay.
No, we still have time.
So
Let's keep moving.
Can I ask you a question?
Yes, you did. Perfect.
Thanks. That's great. This is the Whirlpool Galaxy. This one, Whirlpool Galaxy. This one's really far away. 23 million light years. This is a bit different, right? We were talking about 1,700 light years before. Now this is 23 million light years. One of the most famous galaxies. Who knows it? Who knows this?
Is it Andromeda?
Wow, amazing. It's a Whirlpool Galaxy. Whirlpool.
It's not Andromeda.
No, it's the Whirlpool Galaxy.
You said
It's
that.
called, it's the name. That's the name. So nobody knows it. All right, they always say it's so famous, but yeah. That's the thing, you know, nobody talks about these things. That's why I'm talking about it now. Next. Eskimo Nebula. This one's a double shell planetary nebula. This is 2,870 light years away and is visible with a small telescope in the constellation of Gemini. Well, this is the famous one that probably everybody knows, the Eagle Nebula. This is 7,000 light years away. What was that again?
What's light year again? Just for some people who don't know that.
A light year is the time it takes light to travel in 1 year. Light travels...
The distance.
The distance, correct. The light travels 300,000 kilometers in a second, 7.5 times around the world in 1 second. So in 1 year, we can't imagine anymore how far.
How far is a 1 light year? Do you know? How far is, like, how much?
In kilometers?
In kilometers or meters or?
I couldn't say it in kilometers. It's billions and trillions, probably. Trillions.
It takes 8 minutes for light to go from the sun to the Earth.
Sun.
And it's 126,000 minutes in a year. So 126,000 divided by 8 times the distance between the sun and the Earth.
It takes
Very
it takes 5.5 hours to Pluto, to the outskirts, to the very edge of our solar system. 5.5 hours. Here we're talking about 1 year.
The closest star to the Earth is something
4 light years.
4 light years.
Oh,
You know?
actually, we can...
8.83 to the 12.
Actually,
to the 12.
we can manage the distance from sun to
9
here.
trillion, right?
The light
What's that to the
come
right?
from the sun to here will use the 8 minutes.
Quadrillion, that's right.
8.8 to 12. Cool. Next. This is where stars are born. This is the same thing. Oh, sorry. By the way, it's 70 light years, 55 light years in size.
This
This
thing?
thing is the one before
last
the Eagle Nebula. It's huge. It's absolutely gigantic. Our planet's nothing in comparison to that. Just a speck of dust, really. Nothing. This thing as well. This thing is the Spire Eagle Nebula. This is 9.5 light years in height. 9.5 light years. Huge. This is where stars are born. 8,000 light years away. This one. And it's expanding at a speed of 50 kilometers per second. Cool. Next. And, oh, sorry, I was talking about the Ant Nebula already. This is not, that's just part of the Eagle Nebula. This is the Ant Nebula, MZ.
So these are all different